So this is an example of the data that we can get back. This is the CHAOS project, the 2 years that we had these moorings deployed. So it's off the Icy Cape line up there in the top, and the colors correspond to the moorings. So inshore, midshore, offshore. And this shows the bowhead whales. It goes from September 2010 to September 2012. The grayed out areas are just where the recorder failed. We had some issues with that in the past, which hopefully we've, for the past couple of years, have not had. So basically on the y-axis here, it's the number of time intervals in the day where a bowhead whale call was heard. So we divided a day into 3-minute segments. So if a day has 100%, that means every single 3-minute section in that day had a bowhead call. And from this, we can look at the migrations going by. So for the inshore, you can see this is the fall migration passing by, and then the spring migration, and the fall migration, and the spring migration. You don't really see that spring migration on the offshores because the bowheads use the leads in the spring going through. So they're really concentrated close to the shore. Another thing that's kind of interesting in our data is we see these three, the pulse of whales going by is actually a triple pulse, and this kind of corresponds to what whalers have seen in the past with different cohorts of individuals, the cows and calves and the adults moving through at different times. And we're hoping to look at that a little closer in the future. So bowhead whales are quite different than bearded seals, which just basically start ramping up and never shut up, of course. So Stephanie is one of our analysts that does this all day long, and it's our source of noise. Bearded seals, they are really noisy. And then this is walrus, which is quite interesting in that in the offshore mooring, we have walrus calling in the wintertime where nobody ever expected walrus to be way offshore. That's 140 nautical miles offshore Icy Cape in the middle of the winter in both years, so it wasn't just a fluke in 1 year. So this is some of the data we can get oceanographically from these moorings. So this is the mooring, the inshore Icy Cape mooring here, and this is Barrow Canyon, and this is actually showing an upwelling coming from Barrow Canyon up onto the Chukchi shelf. So here you've got the currents kind of increasing. It's bringing warmer temperature and more salinity. The oxygen's decreasing. The ice cover really drops, and then there's a lot of junk in the water. So that's kind of interesting. And as it turns out, we placed the Icy Cape line there because it was between the Berger and Klondike lease areas, but it ends up being a really great transect to be watching the currents coming up from the south and then over from Barrow Canyon. So we're hoping to keep that going in the future. This is just showing ice. So the blue line here is just the percent ice cover that we can get from satellites. So the ice comes in, it's thick cover and going down. This is the ice kills from our instruments looking up. So even though there's 100% ice cover, there's really not that much ice there. It builds over the winter. And this is at the middle Icy Cape line, and it's the 3 years of the CHAOS study showing that. And you can see right here in this 2012, 2013, in February of 2013, the ice thickness really drops. And that corresponds to that breakup of ice that everybody saw off of Barrow, where the ice just kind of went very quickly. And right around that time, the ice profiler was measuring wave heights of over 4 meters. That's in the middle of the winter when it should be covered with ice. So that's the sort of thing these instruments can track. And then pulling it all together, this is kind of a busy slide, but it's basically the blackest is bowheads in the midshore mooring. So this is the fall migration and then the other fall migration. And it's plotting all the other parameters from all the other instruments on there. So for example, you can see the ice thickness, the ice concentration is 100%. The bowheads are still moving through with that. They stop about when the ice thickness gets to about a half a meter. Which is nothing natives don't already know, but it's kind of nice to have it spelled out like this. And then there's other parameters we can look at. Just for example, right before this fall migration, there's a peak in chlorophyll, so a lot of nutrients in the water before the whales are moving through. And also an interesting little correlation came out with wind speed. So the whales are not starting their migration until the winds really pick up. So whether that's a cue for them to migrate or just because the winds are pushing the ice in and making them move is something we want to look at in the future. So that's moorings. Along the way, we also do sampling stations, and this is for two purposes. One, to calibrate the moorings that are out there, get a beginning and an end value for each value these moorings are collecting. And also there's some other things we can get from it, which I'll show you soon. So here's all the stations we've done over the years. The greens are the chaos ones, and reds and yellows are the two other projects. For this year, we are only going to be doing the Point Hope line, and we're only going to be doing a CTD, which is just an instrument, and I'll show you a movie soon, which goes down through the water column and measures temperature, salinity, and pressure. For all the rest of these, they also pull a sled along the bottom to capture zooplankton. And they did that on a cruise that was last month off of a NOAA ship, so that's why we're not doing it on our cruise this year. So this is a CTD instrument. It's about that much big and round. It goes down on a crane, and it has a wire that comes back up and gives us information. So there is a GoPro camera on this, and you'll be watching it go through, and you kind of just want to pay attention to the changes in the water as it's going down. And here you're going to see two traces of basically temperature, salinity, and pressure as it goes down. And the interesting thing on this is that you can see the water stratifying and what kind of things are in the water at those stratifications. So I'm going to play this if I can.